Hello everyone, welcome back to ISM 210. Today we will be covering chapter 5, which is about infrastructures and platform sustainable technologies. So, in this chapter, we will first learn about MIS infrastructures, which will be the backbone for supporting operations, change, and sustainability in a business. Next, we will discuss about sustainable technologies, how businesses are building greener, more environmentally responsible system. So, please do keep in mind that I may not go to every single slide line by line, but I'm going to make sure that I cover all the essential topics and examples you need to really understand the important chapter. All right, now let's get started. So first, let's discuss about infrastructure. So what do we understand from the word infrastructure? Infrastructure is nothing but something that includes the build. Let's consider a building. So what is an infrastructure? The things that go into the building, right? Like the bricks, sand, water, the pillars that you construct, the rods, all that is the infrastructure of building. The same way for a management infrastructure, the infrastructure will include how a firm will build, deploy, use, share its data, process the data, and its assets. The five key components in an MIS infrastructure are hardware, which are the physical devices. Next, we have software, which are the program and applications. Next, we have network, which allow the communication and sharing. And the fourth and fifth are the client and server, which are looking into the relationships, the requests, the uploading, the storage, the applications, and everything. So the MIS infrastructure will include the plan and everything, all these components to build, deploy, use, share, and process the data. That is what an MIS infrastructure is. So next, let's see the three primary types in an infrastructure: information, agile, sustainable. So, information MIS infrastructure is nothing but that supports the daily operations. So, these daily operations will have how the companies will protect the information. First, we have the backup and recovery plan. So, backup is nothing but you'll have the same exact copy of information that is in your system. Will you have a backup in your cloud or in your drive? Next, recovery is nothing but restoring the same information when the system has a crash. So, this recovery includes three things. First is the fault tolerance, which is the ability to continue running even when a part fails. So, even one part of the system fails, the other part will still keep on running. Next, we have failover. When the main system fails, there will be a backup system and it will go to that backup system immediately and run. Next, failback. Failback means once the system issue is fixed, it will go back to its original system. So let's say the server one had an issue and you move it to on server two. So when the server one is fixed, you go back to server one. That is what we call it as a failback. Next, we have a disaster recovery plan. So, this disaster recovery plan is something that is done and will be with every company because you don't know what kind of disaster may occur any time. So, this is like a step by step process for recovering from the major disaster. It can be a tsunami, it can be a mice attacks, squirrel attacks, fire, flood, it can be anything. So, in the next, here you have a graph to talk about the disaster to recovery period. So, on the y axis, we have the timeline, and on the y axis, we have the dollars, and on the x axis, I'm sorry, on the y axis, we have the dollars, and in the x axis, we have the time from disaster to recovery. So these 2 points meet, these two lines meet at a point. That point will be the optimal time, which means that even those many dollars and that much time is spent by the company to recover, it will not see any loss. But when the cost is higher along with the time is higher, then there might be a loss for the company. So that's what where both of them will meet is known as the sweet spot. So during the disaster recovery, every company will have a hot site, cold site, and a warm site. Hot site means that facility will be completely equipped with that system so that the company's main, even the main building is in the disaster place or it is devastated or distracted, I'm sorry, distracted, not devastated. If it is distracted, they can go to this hot site and start functioning again. Next, we have a warm site. This site will have the equipment, but it needs to be set up. So there'll be just computers over there. They have to run the data again, they have to keep in the data, they have to set up everything. Next, we have a cold site. So this is an empty space. It does not have any kind of computer equipment, but when there's a disaster, the employees will be shifted to that place. Next, we have the business continuity plan. So, this is a plan that is made how businesses will continue and restore its operations during or an unexpected event. So, this will include emergency preparedness and incident management. So, the main goal of this BCP is that the downtime is very less, which means the time that they spend to recover will be less, and they can make their operations running back to normal in case of a disaster or any kind of critical condition. So in BCP, they prepare for emergency. Emergency is something that is unexpected, emergency preparedness. So they get ready for the event. The company will have a plan first itself, seeing that during a tsunami, we should be prepared for these things. Like we should do this. During a flood, we should do this, like that. Everything will be prepared. And all the employees in the company will be notified about it if something like that happens. So in this BCP, there are some factors that will be affected: the technology, hardware, software, networking, data centers. So these all things also will might be affected during a disaster. So they prepare for these things as well. So there will be a lot of impact they identify. So when they are making a business continuity plan, every company will identify the important factors. So let's talk about a banking system. So if a banking system is crashed or a hacker hacked it, the main first thing will be to make sure that they have stopped the services. So when they restore the services, they check the important points. They make a list of it, what should be first. So it is like they make sure that the people are able to access their money. So that might be their first step. So it will be a step by step plan prepared during this BCP by the company. So what should be taken care of first, next, second, third, fourth, like that, so that then they start to prepare a plan first by taking down all the components, on which level which component should be there. So next we have agile MIS infrastructure. Agile means supports change and flexibility. So it will support the technology changes, and it will be flexible to adapt to new things, and it will respond to technologies and make sure it adapts. So the goal of agile MS infrastructure is see that all its resources are flexible, scalable, and reliable. So here we have the characteristics of agile infrastructure. First, we have accessibility. Accessibility is nothing but users will be able to access the data securely from different locations using any kind of devices. So today you can access your canvas from anywhere. So it is accessible enough. You can see all the data that is on canvas without any kind of geographical limits. So next we have availability. It means this time the system is being available. So today all the companies make sure their systems are available 24 by 7 to everyone. So uh, if you see Canvas, at times do you get messages saying that it will be in maintenance for 2 hours or 3 hours at times. So that time will be at that time will be at a certain in a certain place, that time the system will not be used by most of the users. They make sure that the systems are always available for the users to use. That is what an availability is. Next, we have maintainability. So here is that the systems will easily adapt to the environmental changes or technology changes, updates, and they adjust to its needs as fast as they can. So this agile model is flexible enough to take in all the business changes. Next, we have portability. So it is the ability where the systems can run across different platforms. Like you have WhatsApp today, you can do it. You can run it on a phone, you can run it on a web browser, you can run it on a laptop, you can run it on a tablet. You can run it anywhere that you want. Next, we have reliability. Reliability is that it is providing accurate information and dependable information. So, whatever information the system is giving to you, it is 100% right. So, it is almost the right information and it has all the accuracy. Next, we have scalability, which means that as the demand grows on, it should be able to accommodate a lot of users. So, for example, during Thanksgiving break, you see a lot of websites loading very much slowly. But today, with the technology, lot of websites load as fast as they can. Because if you look at Amazon, even during the Prime or any time, millions of users use it at once, but Amazon will not hang. It is because it is handling all that traffic very good, all their users. So Amazon handles this holiday shopping traffic very well. So they make sure they increase their server capacity for that time period so that the users do not face any kind of disturbance. So next we have usability. Here system is very easy to learn and satisfied to use. So if you look at your Canvas course, every step is clear. Where are the announcements? Where is the module data? Where are your assignments? Where are your quizzes? So everything is structured. If everything is put in one place, then you cannot see it right. If everything is put in one place, you cannot see it. You cannot structure it properly, where to go, how to go. But usability is something where everything is neatly structured, you can learn easily and it can satisfy your need. That is the usability. So these are the characteristics of agile MIS infrastructure: accessibility, availability, maintainability, portability, reliability, scalability, and usability. So this agile infrastructure will help business to be ready for anything, any change it can happen. This infrastructure can take in everything. So the next we have is building sustainable MIS infrastructure. So this is sustainability. How are the companies giving back to the environment today? So we have Moran's law here, where a computer chip's performance will double approximately for every 18 months, making the devices more powerful and cheaper. But today, we are not using a device even for more than 2 years mostly. People are changing their devices pretty much quickly. They are killing the efficiency, they are not making it sustainable. So with these technology growth, they are creating some other problems such as e-waste, energy consumption, carbon emissions. E-waste is nothing but discarding those electronics, your phones, computers. These are not disposable, these are undisposable. These chips, the screens, they just throw away the devices, they cannot be decomposed into the land. These do harm the environment. Next, we have energy consumption. Today, technology needs a lot of power. Today, supercomputers need a lot of powers to run. Servers need a lot of powers to run. It means we are emitting a lot of carbon emissions. The data centers are using all those things today. Next, we have carbon emissions, which continue device usage. The device usage increases, the carbon footprint increases. Today, all the data centers consume are running on our fossil fuels and things around, so it is consuming a lot of our fossil fuel energy. So we have our sustainable and green MIS. Today, a lot of companies aim to reduce this environmental impact by designing it smarter and using the technology very well, and even the disposal of technology in a good way so that it does not harm the environment. So it is always important that we use technology responsibly. The technology must evolve responsibility to protect our planet. So we have spoken about e-waste, electronic waste, and carbon emissions. So, with supporting the sustainable mass infrastructure, today businesses are investing in grid computing, virtualization, and cloud computing. Now, let's see what do they mean. First, let's talk about grid computing. This means that using a lot of computers together to solve a problem faster and efficiently. It's like thinking distributed problem solving. So, in simple ways to say, we can say that instead of one system doing all the work, they divide the work between hundreds of systems or thousands of systems, and all these systems work together on that single problem. So, here the energy that is consumed by each system reduces rather than giving all that energy to a single computer, and it processes the data. That is known as grid computing, and this is often does not matter on any geographical location. It can be done. Next, we have virtualized computing. So this is creating multiple virtual environments on a single device. So if we talk about VMware, if you have heard about it, so on a Mac system, I can install a Windows today. So my Windows will be my virtual machine. So on a single system, they try to create multiple VMwares, and each VMware will run its own application. So they do not need to provide the power for 10 different systems, because 10 different systems doing different work, because they just provide the current for one system, the power for one system, and that one system is generating 10 different applications for them. It's running and giving them 10 different results. So that is what virtualization is. So in simple to say, one server will run many virtual machines instead of having multiple physical servers. So in this virtual computings today, we have data centers. So traditionally, data centers consume a lot of energy, but today they are making the data centers also sustainable by reducing carbon emissions, focusing on floor space, and next choosing geographical location. So geographical location also does matter in a data center, because data centers consume a lot of energy and they need to cool down, so there should be a cooling system as well. So these data centers are located on and off on geographical locations, but where there are cooler temperatures, and regions where they access a lot of renewable energy like solar energy is used more than the electricity. So they look at favorable conditions and set up these data centers. And when we are talking about floor space, as I told before, instead of setting so many physical servers, they set up one server and they run more virtual machines on that. So because of this, they are seeing in a different location using the renewable energy resources. Even the carbon emission that is emitted from the data centers will be reduced. Next, we have cloud computing. So this cloud computing is nothing but where you use the internet to store, manage, and process your data. So this cloud computing is also similar to your agile MIS infrastructures. So if you heard about AWS, Amazon Web Services, GCP, Google Cloud Provider Services. These are the cloud services which are provided by the companies to other companies, where other companies can store their data directly on their cloud. They need not set up large data centers or large databases to store their data. They can just directly store it on the cloud, which helps the environment a lot. So there are different advantages for cloud computing, like accessibility. So anywhere you are able to access your data. Like I told about Canvas, and during COVID, every employee was working from different geographical locations. Next, cost savings. So this cloud space is like, if a company is running a data center, so they have to always put money in that data center to keep it running. But in this cloud space, let's say they have taken 100 GB, but they only use 20 GB. So the company will only pay for that 20 GB. They need not pay for all that 100 GB they took. They will only pay for the amount, pay for that space that they used. Next, flexibility. So they can scale up that 100 GB to 1000 GB according to their needs and requirements whenever they want. Next, reliability. As I told you today, all these cloud service providers make sure that the system is running 24 by 7. It is available to their users. Next, portability. So today the data is easy to migrate and access on different platforms. If a company wants to shift from AWS cloud to GCP, it is pretty much easy. That data can be transferred with a specific in a specific time without needing some kind of specific hardware or outside needs. So there is easy data migration and access. Next, Availability, as I told you, the system is available 24 by 7 today for the users. Scalability, scaling up their resources, same like flexibility. When there is use, they increase the resources. When they don't, they don't. Next, backup and recovery. When the system is not available, there will always be a backup cloud server ready. So if the main server is not working, all the company's data will be in the backup server, and the employees can use the backup server and use the data that is in there. Even that is provided in the cloud environment. Capacity on demand, same like your scalability and flexibility. They adjust it according to the storage they need and according to the capacity. It does not need any other hardware or extra space to keep on storing the data. So these are the different advantages, and due to less physical server space, we are giving a lot back to the environment. No carbon emissions, no e-waste, a lot generated, all these things. Next, in cloud computing, we do have four different factors: private, public, hybrid, and community cloud. Private cloud is for banks and corporations, kind institutions where they cannot share their cloud with anyone. They can have their own cloud and they need to store their own data in the cloud. Nobody can get access to that. Next, we have public cloud. So the Amazon EC2 and Azure, these things are the clouds where it is easily accessible to everyone, and this is managed by third-party providers. So anybody who has that cloud access can look into the data. Next, we have hybrid cloud, which is a mix of both public and private clouds. If a company is having a hybrid cloud, in the private cloud, they store the data that nobody can see, and in the public cloud, they store the data that everybody can see who has access to that cloud. Next, we have community cloud. This cloud is shared between organizations that working on the same agenda. So often when they are doing collaboration, let's say a government is doing a healthcare project with the company, so both of them share one cloud which has a lot of security as well at the same time. So when they are sharing those common interests and collaborating, that is when they use this community cloud. So all these cloud services will help the businesses with different options like storing, managing the data, processing their data. They need not depend upon any other security or flexibility. The cloud will be responsible for everything. Their cloud service provider will be the one that will be responsible to manage everything regarding their data, providing security, flexibility, costing, and everything. So in this cloud, we do have, as I told before, we have three kinds of cloud services: software as a service, platform as a service, infrastructure as a service. So as I told you, cloud computing is a pay per use revenue model. So if you use only 20 GB space, you pay for that. If you use 100, you only pay for that. Suddenly you need 1,000, you use that and you pay for that certain amount of time. Even if you use it for a day, you just pay it for a day. That is why cloud computing is being more used these days. So in the infrastructure, um, the here in the infrastructure, it will look at the hardware networking capabilities. It's like using, which includes the use of the server, storage in the cloud, dynamic scaling, which means that the infrastructure can be automatically scaled up and down. And in the software, it is responsible for delivering the applications over the cloud. And platform as the service will look into the deployment of the entire system, which includes hardware, networking, applications. So as they use it, they are going to need it and then move forward. They're just going to pay for that. So with this, we finish our chapter 5. And the main things that we have learned in this chapter is that MIS infrastructures are very solid and critical for supporting our operations, enabling change, and ensuring sustainability. Business must always plan to grow with unexpected failures. There'll be a lot of things, and they should make sure they are giving back to the environment as well. Building smarter and greater infrastructures isn't just good for business, it's good for the world. So, thank you for learning with me today. And this will be the last chapter for your ISM 210. Thank you for joining my class.